Morning guys, today we're looking at simplifying and equivalent fractions, so two certain sections of our fractions work. Hopefully we know the difference between our improper fractions and our mixed numbers, so this is the next stage in that series. First of all, we're going to look at what an equivalent fraction actually means. To do this, we're going to start off by looking at a very basic diagram. Okay, I'm going to split that into halves. We'll do three of them to start with. Okay. So what we're looking at is, first of all, a very simple diagram where we have the first shape is split into halves. So if I, let's say, shade 1/2 of that, or ask you to shade 1/2 of that, that's pretty much what we would do. Okay, so what an equivalent fraction means. An equivalent fraction looks at the exact same size fraction, but just split up into different pieces, or different amount of pieces. So for example, we're still going to do this 1/2, but what I'm going to do now, instead of having it as in a half, I'm going to now split this shape up into quarters. It's still exactly the same amount. The size of the fraction is exactly the same, but now instead of having 1/2, we've got 2/4. Okay, so it's still exactly the same size. Likewise, I'm going to shade in a half of this fraction here. But this time, this is what I'm going to do. I'm going to do the same thing. I'm going to put it into quarters. So now I've got 2/4. But now I'm going to draw a line all the way through. Can you count what that means? 1, 2, 3, 4. We've now got 4 out of 5, 6, 7, 8. I've now got 4 out of 8. So again, the exact same size of the fraction has been shaded. Nothing about the actual size of the fraction has changed, apart from the actual number here looks different. But you might notice something. Well, can you notice something? If we've got a half, and we know that it equals 2/4, which equals 4/8, because all these things are exactly the same size, they're all equal, can you see any relationship between how to go from a half to a quarter? Now, hopefully what you may have said, because I mean these are all equivalent fractions. These equivalent means they are the same, or they have the same, they mean the same. Okay, which they all mean the same thing. They all mean the same as this 1/2. Hopefully what you might have recognized, to go from 1/2 to 2/4, if I double the top, or times it by 2, and I double the bottom, times it by 2, we then get 2/4. If I double the top, to make 2 times 2 is 4, I'm going to double the bottom, 4 times 2 is 8, we get the 4/8. So if I multiply the top and the bottom by the exact same number, we don't actually change the amount of the fraction, or the size of the fraction, but we do create an equivalent fraction, or a fraction that means the same thing. Can you think of something else that might mean 4/8? Let's double it again. What's double 4? It's 8. Double 8 is 16. What if we times, let's say, 1 by 10? What's 1 times 10? Well, that's 10. What's 2 times 10? 20. Look at that. What if I do the second one here and times it by 50? What's 2 times 50? Well, that's 100. What's 4 times 50? That's 200. It's another equivalent fraction. All these fractions here mean exactly the same thing. They mean 1/2. It's just they look bigger, but it's what often we call they're all in the same ratio. Okay, they all mean exactly the same thing. So let's have a look at another question. Let's have a look at the fraction, let's say 3/5. Well, using the same rule, can you give me another equivalent fraction of 3/5? What about 6/10? Or let's times it by 3 this time. And 3 times 3 is 9, 5 times 3 is 15. Or let's say we times this by, let's say, 20. 3 times 20 is 60. 5 times 20 is 100. We could times it by 300, or by 100, make it that. We could times it by 1,000 and make it that. Okay, it's endless. It's an infinite different amount of fractions. But all these fractions, absolutely every single one, all mean the exact same thing, which is that 3/5. So equivalent fractions just means that you times the top. So we multiply the top and the bottom by the same number. Now, the more challenging questions might be something that looks like this. X over 3 is equal to, let's say, 6 over 9. And they might say that these two fractions, they are equivalent. And that's what the equals means. They are equivalent. Now, X represents a number. Or, in this case, the numerator. And they would ask to say, well, if these two fractions are equal, or they're equivalent, what must the value of that top part be, that x? Sometimes they might put a little square there. It means the same thing. So what we do here, we say, well, okay, if they're equivalent, it means that I've times the bottom and the top by the same number. Well, what do I times 3 by to make 9? Well, 3 times 3 makes 9. What times 3 makes 6? Well, 2 times 3 makes 6. So we know that the missing number there is 2. What about, we have 4/5 equals, let's say, 16 over a box, or a letter, like an X or a Y, which again, this means that any sort of number. Let's do the same thing. 4 times 4 makes 16, so 5 times 4 makes 20. How cool is that? So we get our missing number. Okay, so that's all our stuff on equivalent fractions. You can see how we can find the missing numbers when needs be. Now let's have a look at that second thing, which is looking at simplifying. Now the good thing is we've actually already looked at what simplifying fractions are. It's just we've looked at it the opposite way. Before we looked at things like this, a half, which equals 2/4, which equals 3/6, which equals 4/8, which equals 100 over 200, which equals 500 over 1,000. Okay, I'm just doubling or timesing it by the same number. Okay, all those fractions are equal, so they are all equivalent. Okay, we've already done that. So what simplifying means? Simplifying means that we start with a fraction. But the aim is to go all the way down to the smallest fraction. So we start with a fraction, but we make it as small as we can. So in other words, we look for that smallest version. So for example, we might say a question like, simplify 100 over 200. Now obviously we can look at this and say, well, that's 100 over 200, that's what we're starting with. So these are all equivalent. So a half is going to be my simplified fraction. But how do we actually get that apart from starting at a half and going there? Well, likewise, when we said before, we can times the top and bottom. For example, if we did this one, we times by 100, top and bottom, to get the 100 over 200. We can also divide the top and bottom by the same number. And that's basically what we're doing. So we're looking at this and saying, well, what can we times this by? Now, we could just divide by 100 because that's the same as crossing 2 zeros off. Look at that, a half. Sometimes you might start and go from 100 over 200, you might go a half of it, and then a half of it, and then divide it by whatever numbers you can. In this case, it might be 5 over 10, and then 1 over 2. Okay, so sometimes you might start high and write lots of different fractions until you get to the smallest one. Sometimes you might be able to see the biggest number that goes into it straight away. Now obviously, if you can see the biggest number possible that you can divide, then that's the best way to do it. So let's say we've got a question like this. It says simplify, let's say 20 out of 25. Okay, so let's see what number goes into both of these. Well, hopefully you said 5. So let's divide the top and bottom by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. And look at that. We're now down to the smallest possible number. I know it's the smallest possible number because I know that nothing else goes into 4 and 5. Particularly that 5, in this case, is a prime number. And the only other number that goes into 5 is 5, which obviously we can't do anymore. So let's have a look at another one. Let's do 15 over, I'm using all 5s, aren't I? Over, let's say 60. Okay, so I gave you a bit of a hint there and said, okay, well, I'm using 5. So how many 5s are in 15? Well, 5 times 3 is 15. How many 5s are in 60? Well, 12. But hold on, you might notice something. We can actually go further because 3 goes into 3 once, 3 goes into 12 4 times. I can actually go down to a quarter. So we always want to keep on going down as far as we possibly can. Let's do the next one. Let's do 18 out of 60. Now look at that. I might not. I mean, it could be 3, it could be 6. We're not too sure. But let's go the long way. Let's halve it. What's half of 18? 9. Half of 60 is 30. Okay, what's half of 9? Well, no, that doesn't work. So that's 4.5. What goes into 9 and 30? Well, you might have said 3 goes into 9 3 times. 3 goes into 10. So 3 goes into 30 10 times. And look at that. 3/10 is the smallest number because 3, again, is a prime and doesn't go into 10. What could you have actually divided 18 by to go straight down to 3? Well, you might say 18 divided by 6. We could have done it that way as well, and that way we would have gone straight to the answer. So again, an equivalent fraction is where often we can times or sometimes even divide to get to an equivalent fraction. So a fraction that, although it means the same size, it just looks differently. When we simplify, we start with one of the bigger fractions and we work all the way down till we can get to that smallest possible fraction. It's always a good thing to make sure that in any question, if we're giving our answer as a fraction, we always make it as simplest as possible. Hope this was of use to you. You probably already knew it anyway, but if you didn't, hopefully you got something out of it. Have a great week, guys.